last half. Damn. I have not had enough coffee yet today. That must be the explanation. Okay. Let's move on. So next, right, to determine probabilities of random chance things, we must do simulations, right? We have to do long-run simulations to help determine probabilities or to confirm probabilities. Definition of a simulation, right, is the imitation of chance behavior based on a model that accurately reflects the situation. This is called a simulation. This is our definition that we will be using. It's somewhat intuitive. We kind of know what a simulation is, or could be, just based on our own experiences. The 1 in 6 game where we roll dice to simulate buying sodas and winning a prize. Can't spell today either. Right, this was a simulation, and it allowed us to quickly determine if the probability was reasonable without going out and buying sodas. Right? Saves money, saves time. We get a result rather quickly. So, you know, that simulation accurately portrayed what was going on, right? We had 7 friends, so we rolled the dice 7 times. 1 in 6 wins, so 1 through 5 was a loser. Rolling a 6 was a winner. It's a fair dice, so all of the sides have an equal chance of happening. Right? So that scenario helps portray what we actually want to know about, which is the sodas and winning the prize. Oops, sorry. Before that, does anyone have a moment to write down the definition if you're taking notes? Okay, it looks good. I see no hands. All right. So there are 4 steps of performing a simulation. Step 1 is state. Ask a question of interest about some chance process. Step 2 is plan. Describe how to use a chance device to imitate 1 repetition of the process. Tell what you will record at the end of each repetition. Right? The planning step is very important. Right? The state part, the question, is probably something that will be provided. Right? If you're given a problem, they're going to ask you a specific question. Right? The plan is something you're going to have to come up with yourself. Right? Are you going to use rolling a dice? Are you going to use flipping a coin? Are you going to use a random number generator? You know, there's these different things that we can use to create random occurrences of something. Right? And then we need to say how we're going to use that, what it's going to represent, and then what we're going to record. Step 3, perform many repetitions of the simulation. And 4, conclude. Use the results of your simulation to answer the question of interest. All right. So this I suggest you write down if you're taking notes. You want to make sure that when you're asked to describe a simulation, you should do these 4 things. Or to perform a simulation, let's perform a simulation. If you're asked to describe, you need to do step 2. All right. Can you raise your hand if you need a moment to write this down? So now let's think of our 4 steps along with our 1 in 6 game that we did on Monday. So step 1, state what's the probability that 3 or more of 7 people who buy a soda win a prize if each bottle has a 1 in 6 chance of saying you're a winner. Gosh, it's very apparent today that there's good reasons why I don't teach English. I've had lots of spelling errors today. Whee. Step 2, plan. Use a 6-sided die to determine the outcome for each person's bottle of soda. A 6 is a wins a prize. 1 through 5, no prize. Roll the die 7 times, once for each person. Record the number of people who win a prize. Right? This is our plan. Right? Do have each student perform several repetitions. This is what we did. Right? I had all the guys use the dice rolling, simulator, a virtual dice roller. Rolled the dice. We recorded our results. I used those results. We made a dot plot. Looked at it. Right? Conclude. Right? Now this was a different question than what we answered on Monday. We were simply asking, does it seem reasonable? Based on our simulation, it seemed mostly reasonable. Right? Out of 125 total repetitions of the simulation, there were 15 times when 3 or more of the 7 people won a prize. So our estimate of the probability is 15 out of 125, or about 12%. It seems plausible that the company is telling the truth. Okay? So notice the amount of detail that's included in the conclusion. All right? It's not just yes, all right? Or the probability is. It's giving what actually happened. It's describing what occurred. It's not just the probability is about 12%. Okay? It's giving a lot more detail than that. All right? So we need a moment to write any of this down. Does anyone have any questions about this scenario? All right. Next. All right. Let's see here. I think this will work. So we have a video here that I'm taking from the textbook resources, showing how to use the 4 steps in conducting a simulation. It's a little different than what we've done. So let's see if I can make this work.
Hi, this is Jason Oleski. In this example, we'll take a look.
Can you guys hear it? Yes. All right. Hooray.
Look at how we can use technology to perform a simulation. Suppose in an attempt to increase sales, a breakfast cereal company decides to offer a NASCAR promotion. In each box of their cereal, they'll put one collectible card featuring a NASCAR driver, either Jeff Gordon, Dale Earnhardt Jr., Tony Stewart, Danica Patrick, or Jimmy Johnson. Now the company says each of the 5 cards is equally likely to appear in any box of cereal. Now suppose a NASCAR fan decides to keep buying boxes of the cereal until she has all 5 of the driver's cards. She's surprised when it takes her 23 boxes to get the full set. Our question is, should she be surprised?
All right, so something important is this middle sentence here. The company says that each of the 5 cards is equally likely to appear. That's an important piece of information that we have to consider when we're setting up the, when we're planning our simulation. Okay, equally likely, that means, so there's 5 cards. We can just like use numbers 1 through 5, so to say.
So for the problem, we want to answer the question, what's the probability that it'll take 23 or more boxes to get a full set of 5 NASCAR collectible cards? Since we don't want to buy box after box after box of this imaginary cereal, we'll let our calculators simulate the situation for us. So for our plan, we'll need 5 numbers to represent the 5 possible cards. Well, the easiest thing we can do is let 1 equal Jeff Gordon, 2 equal Dale Earnhardt Jr., 3 equal Tony Stewart, 4 equal Danica Patrick, and 5 equal Jimmy Johnson. Next, we can use the rand_int feature on our calculator to simulate buying 1 box of cereal and looking at which card is inside.
Okay. Here's where to find the rand_int feature on your calculator. All right, we're going to go to, what was it? Math. So there's a button on your calculator that actually says math. It's underneath second and alpha. And in these options, you're going to go over to the PRB tab, probability. All right. There is where you will see rand_int. We'll probably end up using the NCR and possibly the NPR functions. Those are other things. But yeah, we want the rand_int function. All right, so we can press 5 or scroll down to 5. Right, in this case, it wants a random integer between 1, and 5. So that's all I put into it. I ask for this command rand_int, and I say I want a number between 1 and 5. And you press enter. First number returned was 1. If I want to do this again, I can just press enter again. It'll repeat. And I just press enter however many times I need to. Okay, so this is where we find the random integer generator on your calculator, which can be very useful. All right. Anyone have any questions on that? Good. Okay. Continue.
Whichever value comes up will correspond to one of the 5 drivers. Because we want a full set of cards, we'll just keep pressing enter until we get all 5 of the labels from 1 to 5. Then we'll record the number of boxes that we had to open. So suppose we performed 1 repetition, and this is what happened. In our first pressing of rand_int 1,5, we got a 3. In the next case, we got a 5, then 2, then 1. Already in the first 4 simulated boxes of cereal, we've gotten 4 of the different drivers. But now suppose a 5 came up. We've now gotten a double of 2 of the cards. 2, 3, and 5 were already drawn, and finally we get a 4 on our 9th box. So in this repetition, it took 9 boxes to get a full set of 5 NASCAR driver cards. Then suppose in the next repetition, it took us 16 boxes, then 10 boxes, then 15 boxes, and finally a case where it took 22 boxes for us to receive the full set. Now, if we were to continue this simulation on and on and on for 50 repetitions, this is what might happen. This is a Fathom dot plot of a simulated 50 repetition case. Notice in this dot plot, there was never an instance where we had 23 or more boxes necessary to get the full set. In fact, in most cases, it only took around 10 to 12 boxes or so to get the full set. So for our conclusion, we never had to buy more than 22 boxes to get the full set in our simulation. So our estimate of the probability that it would take 23 or more boxes to get a full set is roughly 0. The NASCAR fan should be surprised about how many boxes she had to buy. For some additional practice with simulations with technology, try exercise 25.
There you go. You guys have any questions about this example? And I'll put the link for this video into, well, it's already in our live class resources, so you'll be able to watch this video again if you want to. But are there any questions about this example? All right. So now let's look at another simulation here, but in this case, let's suppose we have an unfair coin. All right. So rather than a coin that has 50-50 shot of being heads or tails, we have a coin that has a probability of heads of 0.6 or 60% and tails of 0.4 or 40%. What would you have to do to simulate this property, or this properly? Sorry. All right. So for me, in this scenario, what I would do is say, okay, well, let heads be represented by numbers 1 through 6. Right. And tails be numbers 7 through 10. Use a random number generator. Right, to get values. From 1 through 10. And record, right, the number of tails. Right. So this is an example. Now this is more specific to the question that follows. The first sentence just has to do how we can simulate this. Use a random number generator. Have numbers 1 through 6 apply to heads. Numbers 7 through 10 apply to tails. Right. And what that does is it gives us 6 possibilities for heads, 4 possibilities for tails, which aligns with 60% heads and 40% tails. So I've used a set of numbers that allows me to have that proper breakdown of the percentages and the proportions. All right, and so then we want to say, what is the probability that you will flip 3 or more tails in 10 flips of this unfair coin? All right, so we have 3 or more, and we have 10 flips. And we want tails, so we're keeping track of tails rather than heads. In this scenario. Okay, so this is what I was working on before class started. Now, to do enough samples, right, maybe we'd want to do like 100 repetitions of this, which would mean you'd have to press the random integer function on your calculator 1,000 times. That's going to take a long time. All right. We don't got time for that. So we needed an alternate thing to use. And now my first thought, because I'm comfortable trying to use Excel, I'm not excellent at it, was to try to get Excel to run the simulation for me, which I hadn't finished entirely. Oy, come on, there we go. So this is what I had so far. Let's zoom in a little bit. Let's make this bigger. Come on. What's going on here? It's upset with me. Oh, that's why. I'm still in here. No. Okay, we go. Blah, 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 blah. I might be what I need to do. Anyway, I may have just solved my problem while looking at this. Let's see here. I don't want that. Anyhow, I just want this to not be clicking in here right now. No, I don't want that either. Stop it. All right. So what I did here was I used Excel. And I ran 100 simulations of flipping a coin using the random number generator in Excel. So I didn't have to like press enter a bunch of times. I essentially put the command equals rand between 1 through 10, right? Because I want numbers between 1 and 10. I put that in the first cell. Oh, man. Why is it being this way? Nope. Stop. Good. I'm just ruining everything right now. Why is Excel being so mean to me? All right, so I put my formula in the first cell. Once you have a formula in a cell, if you want it repeated, you just get this little plus thing and you across to the other cells you want it done in. All right, this is set up to the point that if I update one cell, it does all of them again. So I could theoretically reuse this over and over to do 100 simulations at a time and record my results somewhere. That's a more advanced thing. So anyway, this gives me my results. It does all the simulations. There is another command that I was trying to figure out how to do to tell me if there was 3 or more occurrences of a number, or to count how many times a number happened, and then I could give it another command to do stuff. Anyway, there's things out there that will run the simulation for you. This was the first thing I thought of because it's on a computer. But I'm going to look into other ways of doing simulations as well and share that with you guys. Anywho. So I don't have an answer to this question yet because I wasn't able to finish my simulation, but I have all my flips of a coin done. So there's that. Sorry if that seemed pointless, but I think it's interesting. I'm trying to figure it out. All right, so then the main idea of this, the reason I'm giving this example is because we need to consider how to account for unfairness or not equal likeliness for the discussion board that we will have, that I'm going to show now. So we're going to end that. Yes, I want to keep that. We're going to go here, here, here. All right. I need. All right, so here we go. In the NASCAR example, each of the cards had the same chance of being in any given box of cereal. That is, they were each equally likely to happen. What if the cereal company decided to make it harder to get some drivers' cards than others? For instance, what if the chance that each card appears in a box of cereal is 10% for Jeff Gordon, 30% for Dale Earnhardt Jr., 20% for Tony Stewart, 25% for Danica Patrick, and 15% for Jimmy Johnson? How would you modify the simulation in the example to estimate the chance that a fan would have to buy 23 or more boxes to get the full set? You do not need to do the simulation. You just need to state how you would modify the simulation so that you could estimate the chance that a fan would have to buy 23 or more boxes to get the full set. So you're going to mirror a lot of what was done in the simulation that we looked at in the video, but you need to change how they determined which cards showed up. Okay, are there any questions about that? Okay. All right. So then, that's it. I'm going to stop sharing my screen. All right. If there's anything else you would like help with, or sport on today, please stick around and let me know. I'd be happy to talk to you about how I can help you, whether it be for something in this class, a previous assignment, anything like that. You need another example of something, I'd be happy to do that. Otherwise, you are free to go and enjoy the rest of your Thursday, and have a good Friday and a lovely weekend, and I will see you on Tuesday. Right.